Let's imagine a scenario where a hacker attacks hospitals' data and tries to delete it completely, or in the event of a cyber attack that disrupts airport operations, making a chain reaction of connected events. Undying Totem ensures that passenger information and flight details remain accessible, securing both passenger management and airport security operations. How would we resist such attacks? Has humanity thought of something creative yet? CAS, Content Addressable Storage, system that stores information based on its content, not name or location. But still, how does it help security? Imagine if every piece of data had a unique fingerprint based on its content. This means that any changes to the data, no matter how small, would result in a completely different fingerprint. So, if someone tries to alter the data, even a tiny bit, the fingerprint changes and the system CAS detects the manipulation. Not to mention, once data is stored in the system, it cannot be changed. To make it reliable, content CAS can be replicated across multiple sections in the network, which will be available even during cyber attacks and network problems. CAS also uses P2P, peer-to-peer network sharing. To put simply, devices can talk to each other without needing a middleman. No single part of the system is in complete control. Information is spread across all parts. If one part fails, others take over. Since there is no central point of failure, the system keeps running smoothly even if something small goes wrong. IPFS, Interplanetary File System, uses content addressing to uniquely identify each file in a global namespace, connecting IPFS hosts and providing decentralized storage.
For example, AWS has centralized storage, meaning there is always a single point of failure. But decentralized storage copies files across multiple servers, so if one service goes down, others are there to protect your data. But how do you figure out whether a file is part of the system or not? Bloom filters.
Suppose you run a website where users post links. 99% are cat pictures, cool websites, and YouTube videos. But every once in a while, someone posts a link to a known malicious site which you want to block. There's millions of known bad links, so you pay for a service that keeps a list of them that you can query. Calling out to the service costs money and slows down your response time to your users. So you'd really like to know whether a link is bad without querying the service. With a Bloom filter, we could cut down on 98% of calls to the service using only 10 megabytes of extra memory.
Thank you, Alex, for the amazing presentation. Now we can go ahead and go through the code walkthrough and the demo. So let's go ahead and go with the first step. Just to give the idea, the app has been deployed in Vercel and the tech stack uses Next.js as well as 3Web for our IPFS environment. So let's go ahead and upload a file. Okay. Once we click on upload, the file gets uploaded, we get a URI. We can access this particular URI to directly look at the image, or we can just quickly use the hash key. The hash key gives us access to the power of the decentralized mechanism, so to obtain that particular file. So let's copy the hash key. This is the latest hash that has been generated for this file. Using this hash key, we store it at a particular file, and we can run this script to give us a list of hashes that we have stored. And as you can see, this is the hash that has been added. So we can go ahead and open this particular file. Yep, as you can see, the file is accessible. This is a different URI than the one that we had seen. This is on the IPFS decentralized network. So this is the URI that will be used to retrieve this particular file. On the website side, we have showcase environment where we show certain images, and that's about it. Thank you.
What we have explored, what stood out, what we have learned. Thank you for listening.